So, irrespective of the fact that whether you're physically present or virtually present, can anyone hear me loud and clear? So, if you have any issues with audio or seeing my screen, feel free to ping me or just mention it. We can, at least we are able to hear you, right? So, I'm getting a few yeses right now. So, I'll try taking this forward. So, we've been expecting to have this for a while now. So, I'm very excited that we are finally here. And I don't know what your expectation is out of this seminar, but let's just hope it's a mutual win-win situation. So we are here to discuss machine learning, and we are here to discuss how that is implemented with Python, right? So just a quick show of hands for everyone who's present. Anyone from engineering background? Okay, so physical, that is 1, 2, 3, 4 people. And
There are
says yes,
four
Paul
people
says
inside.
yes, Pranal says yes, Piyush says yes, and there's a lot of yeses. So, all right. So, anyone from non-engineering backgrounds? Okay, 1, 2, and Ranjit says yes to that, right? Okay. So, a couple of people from non-engineering backgrounds too. So, we are here to learn what is machine learning with Python, and we are here to learn who all can fit into it, right? So, let's just move on. Let me introduce myself first. I'm Vivek, and I'm working as a data scientist in an MNC for a while now. And I'm here to represent Ivy Professional School today. Uh, well, one thing worth mentioning is that I myself am an alumni of Ivy Professional School. So I've gone through the full circle. So a few months back, or rather a year or so back, I was just sitting on your side, and now I'm here, right? So that kind of says it all. So we are no strangers to the analytics wave, right? We are practically legacy, and we saw everything happen. So for those who don't know, we have trained more than 10,000 professionals. We have tie-ups with corporates. We provide corporate training. So the training that we impart to you is not just something that is our brainchild. We penetrate corporate offices, and we are aware of what they are wanting to learn. We absorb their needs and we impart it to you so that you're readily deployable in the industry, right? So for more information, you can log on to ivproschool.com. I'll be introducing the various channels for communication later. So let's go through the agenda for this seminar. First of all, the first question you should ask sitting here is, what's in it for me? It's all right. Data science is a booming field. Machine learning is a booming field. But what's in it for you? So first off, I'll take data scientist as a skill, right? And what's in it for you? Try to answer that question. Okay, data scientist as a skill then. What's in it for you? Answering that question. So if you look at the job trends, the term data scientist wasn't there in 2011. And since the advent of that term, it's just gone up. And even the roles of statisticians are taking a dip as we speak. So the persons who are being absorbed as business analysts, the trend is shifting towards getting more into data science. So I will be talking about what is the exact difference between more of a business analyst role and what is a data science role. But then let me just show you the rising trend of it. So that tries to capture the essence of why you should enroll with the help of this, right? Why you should get into machine learning. That was job trends. Sorry for the intermittent technical glitches. We're back again. And now comes the main question. What sort of money am I going to earn? Now, this is a very busy slide and probably you can't see things. So I'll try to pass this for you. 2016, business analyst, salary ranges from 3 lakhs per annum to 11 lakhs per annum. That is the range that we're talking about. The median salary being somewhere around 5.5, right? For data scientist, it all starts from 4.5 lakhs per annum. It can scale up to 23 lakhs per annum. Of course, depending upon your skills and how you portray your talent. But the best part is there are no prerequisites. So I just took a survey up front to make sure I'm dealing with not only engineers, but also people from various other backgrounds, to announce to you that you guys can come in and you guys can start contribute just like that. There isn't any prerequisite whatsoever, right? So for you, the career seems lucrative enough and the money seems to be good, right? So moving on, what do you need to possess? What skills do you need to acquire to become a data scientist? So let me tell you a story from end to end, right? Suppose someone walks up to you and asks to predict you a house price. So he just comes to you and he asks, give me a price on a house. So you'll be flabbergasted by that question, right? So what you would try to do is come up with these intelligent counterintuitive questions. So your first question maybe would be, what location are you looking for? And in Bangalore, you say Indira Nagar, or in Kolkata, you say Park Street, and so on, right? So after that, you'll try to zero in on what kind of area the house is. So 1,000, 2,000, 2,500. You'll try to zero in on the number of bedrooms that are there. You try to zero in on the balconies. You'll try to know what floor is it situated on, what are the amenities that are available, right? Is it a society apartment with a swimming pool and a clubhouse or whatever? So based on that, you'll. I'm sorry. Crime rate, like in that locality. Okay, so didn't get your name. Ashish. So Ashish has pointed out one more feature: the crime rate in that locality. That's very intuitive. Thanks for sharing that. So based on these parameters, we'll try to come up with a rough estimate of the price range, right? So based on that, if I'm looking for a 2 BHK with a swimming pool in Indira Nagar, society apartment where the crime rate is moderately low, right? So you'd give me a price of around 20 to 25,000. So from step 1, knowing nothing, to maybe step 10, producing a reasonably accurate estimate of what's going on. How did you do that? That's exactly what we're trying to teach to the machine, right? So you have to collect data about the localities, right? So step 1, going out there in the market and collecting data. And notice that the data that we'll be dealing with can scale up to gigabytes and even terabytes of data. So it's very essential that you have programming concepts as prerequisites. So you can't just manually pass through all the data and learn from it, right? You need to programmatically traverse the data. So programming. After you've done with the programming, you need to come up with intuitive and interactive bars, plots, and charts so that you can visualize your data better and make those data-driven decisions. So visualization, off-the-shelf toolboxes are required. And of course, we are doing everything to generate some business value out of it. So business and domain knowledge is never amiss. So gigabytes and terabytes of data, wherein comes the big data and cloud computing architectures. And after it's all said and done, you want to communicate the information that you found out to me, right? So if you're looking for a flat 2 BHK Indira Nagar society apartment, it ranges from 18 to 20,000. At the end of the day, you want to make this statement. So I, as a client, am not interested in where you went to collect the data, which programming language you used to code, what algorithms you used, what are the tools, what are the plots you used to get some information out of the data. I'm just interested in that end statement. So communication skill, a very essential prerequisite for a data scientist, right? So up until here, do we have any questions? Do you feel that there is some skill you need to acquire, or what are the things we need to go through to acquire those skills, or something like that? If any questions are there, just throw them at me.
No questions from Calcutta.
There doesn't seem to be any, so I'll just move on. So let me take you through the attractive stuff right now. There. Can you guess what's the first image? The left uppermost. Brilliant. So every word that I'm speaking to you right now, they are received by the 3 small bones of your ears, namely malleus, incus, and stapes. That vibration is transferred over to your ear hairs, which vibrate and send over those signals to the auditory cortex. From the auditory cortex, it traverses to the left hemisphere, where finally everything is analyzed, and then your brains come up with the prediction of what exactly I'm trying to say, right? So this is a whole life cycle that we're trying to cover in what, nanoseconds? So you aren't missing any words that I'm saying, right? You're understanding every word that I'm saying. So that's how real time the brain works. And we have moved on to trying to mimic the brain. So coming up with smart search engines, engines that can play chess as intelligent as human can. So there are instances where Google Brain has come up with systems that can defeat Garry Kasparov in chess, and that's big, right? So upper right, the blocks that are arranging and rearranging themselves. Any guesses? That's a little abstract, I guess. So these are human genome data, right? Arranging and rearranging themselves, that's their study. So by the time a person turns 40, he'll start showing some symptoms that he didn't show beforehand, right? So having diabetes or weak knees or lack of calcium or something like that. So if we had studied the DNA of that individual, we could have predicted that with much more reasonable accuracy beforehand, and we could have taken some preventive measures even before the symptoms occurred. So that's the power. So currently, I'm working with a team called Helix right now, which looks at this data. And I can assure you, within 2020, we're going to have some pretty promising results with respect to studying human genome and estimating them better. So bottom left, it's face detection, right? So the moment you whip out your camera phones and you point them at some person, there sits that green box, right? How did we detect that? Through machine learning algorithms, right? And the last image is how the, okay, can I make it move once again? Is it moving? Not really. Okay, that's sad. So this is an MRI image of the left ventricle of the heart. And based on how it expands and contracts, we can come up with a pretty fair estimate of the patient, whether he needs angioplasty or bypass, what is his heart condition, what are his pressure conditions. We can come up with a very fair estimate of that. So for minor heart conditions, we don't need to pay a lot of money to doctors for diagnosing. Maybe someday you'll be able to just punch in your card at a kiosk, it will scan your heart and make those predictions for you, right? So that's where the industry is going towards right now, and that's why these are very exciting times. So to the million-dollar question, what is machine learning? So before I try to explain, is there anyone who wants to take a stab at it? Maybe someone who knows? Anyone? All right. So machine learning is the art and science of making a computer perform a specific task without explicitly programming it. Let me repeat myself. Machine learning is the art and science of making a computer perform a specific task without explicitly programming it. What do I mean by that? So again, if we take the example of Google Brain, let's say chess. So Google Brain is not coded in a way to say something like, if the pawn moves to e7, you move your bishop to f8. It doesn't work that way. So based upon your move, it dynamically estimates all the permutations and combinations of the moves that can be made on the board, and based on that, it is always 10 steps ahead of you, right? So it's pure play mathematics that is coming to play underneath the sheets, wherein you don't have to explicitly specify what the machine has to perform. It performs it anyway, judging by the historical data, right? So that is machine learning in a nutshell. And these are some of the types of machine learning roughly classified. So don't just go by this. It's a very crude classification that I've tried to come up with. Can be broadly classified into supervised and unsupervised learning, right? So predicting house prices, right? So you wouldn't know what kind of prices I would be looking for in Indiranagar if you were not aware of where Indiranagar is and where it works, how it works, right? So if I picked randomly someone and asked you to predict me some house prices of Houston, you'd probably not give me a fair estimate compared to someone who has been living in Houston for 20 years now will be able to give me, right? So you need data to learn. So you need some time to go over the data, churn some sense out of it, recognize patterns, and then come up with your estimate of what's going on. Machine learning works in the same way. At least supervised machine learning does, right? You need some data that has been classified previously. You need to look into that. You need to learn from that, and then you can go out into the external world to learn from mistakes, right? It's more like training your dog, for example. So you throw it a bone and say, go fetch. It won't fetch the first time, right? You smack it if it doesn't fetch. You give it a biscuit if it fetches. So through this process of reinforcement learning, we are trying to zero in upon a system that can do some predictions very accurately, right? So that is supervised learning in a nutshell. So face detection, it needs to know beforehand what a face is, how the eyes are, how the nose are, how the ears are, how the mouth is, right? It needs to have an idea beforehand before it can deploy itself to estimate how face detection works. So what is unsupervised learning? I'm sorry, some people seem to be having audio issues. All right. Okay. So coming to unsupervised learning, whenever we go into YouTube, right, and type just one phrase, news, or yeah, let's just go with news. So what is the expected search results that are going to come? Nowadays, it's not like video one, video two, video three, video four. It's not like that. That's not how the information retrieval of YouTube works as of now. So how does it work? Whenever you search news, you get these chunk of videos. 100 videos talking about tech news, 80 videos talking about news based on politics. So how is it being able to cluster these videos? Through automation, through unsupervised learning. So to implement such a system, we don't need data to learn. We just need to look at data as it comes, and we just have to find patterns in real time and then just say, okay, these two look similar, club them as one cluster. These three look similar, let's just club them as another cluster. So that's how unsupervised learning works. Clubbing news, and suppose, let me give you one more example with respect to the telecom industry. Suppose Vodafone. So Vodafone roughly has 1 million customers, easily, right? So the ideal scenario for Vodafone would be to come up with 1 million different offers, right? To each his own, because we all are different and we all have different needs. So Vodafone should have come up with 1 million offers. So whenever you go to its website, does it really have 1 million offers? Max to max, what, 10, 20, right? So how's it working? It is going through your features, right? So suppose we all belong to the age group of suppose 25 to 35. Some of us are males, some of us are females, some of us are studying, some of us are working. So based on these various features, you are thrown into these various bins, right? So after you get thrown into this bin, a specialized customized offer is made explicitly for your bin, and that offer is pushed in a mass scale to all of you. So if you're getting one offer, maybe out of 1 million customers, 1,000 others receive the same offer, but not the whole set, not the million people, just a bunch, right? So that's how unsupervised learning works. Just remember these two examples, the telecom one and the news one, right? Done. Again, any questions?
I think you mentioned that you don't need data to train.
Right, right.
Could you explain that a bit?
Yeah, sure. So, sorry, I missed your name.
Sure.
Okay. Shoaib here has a question. He's asking, in case of unsupervised learning, we don't need data to train, and in case of supervised learning,
Oh no, I think that's a statement you made. So
yes, yes. So you're having a question about that, is it?
exactly.
Okay. So whenever we're trying to build a system, right, the first thing we need to do is maybe look at some data, trying to figure out what exactly is the system we're trying. Suppose we're predicting house prices, right? So if you just build an application that doesn't have any data in it, you haven't learned from that data, right? If I tell you, give me an estimate of what is the cost at Indiranagar 2 BHK, blah, 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 you won't be able to come up with a fair estimate. And I can prove it to you right now. So if I ask you, what is the price in Dallas of a 1 BHK, 750 square feet with a lawn in front of it, right? You'll have difficulty in predicting, right? Because you don't know. You need data to train, right? But suppose you don't even know what English is about, and I throw to you 500 news articles. If you just look at those articles like pictures, right, you'll be able to find patterns in words, right? And you'll be able to pin them together. So like these look very similar together, so I'll just club them as one. So you can do this clustering task without the training.
Okay.
Are you getting my point?
Yeah.
So clustering without training, unsupervised learning,
Okay.
right?
But I think you used an example. What was the first example you used?
Predicting house prices.
No.
Uh,
For
news.
unsupervised.
I'm sorry.
Unsupervised. For unsupervised, you
Yeah,
used an example.
I used two examples: telecom,
Yeah.
pushing offers, right?
So I guess if you're a new customer, right?
Mhm.
I mean, is it fair to assume that you're probably attempting a clustering exercise like every time there's a new customer coming in? Because you seem to be suggesting that, right?
So let me take it this way.
Let's say you build, I mean, so what my understanding was you built profiles, right?
Right.
Let's say
Right.
different customer profiles.
Right.
You want to push offers, right? I mean, so a new customer comes in, it's very easy to match the customer to at least
One of those
one of
clusters,
those
right?
clusters,
So that's
right?
exactly what we do. We
But
don't.
my point, but I think, but you are looking at data, you are coming with clusters with very distinct profiles before.
Yes, exactly. So,
So you do
very
have a
good
training
point.
phase there.
You do make a good
Which
point.
is why I was just, I asked about that statement that you made.
Mhm.
Simple as that. So I just wanted to know, I mean, this was my assumption because I never worked in the telecom industry. So
Okay. Okay. So let's just take an alternate example, the news one, if you don't mind. So in the news example, what exactly are we trying to do? We're not looking at data beforehand. Suppose you go in there without a plan. That's all I'm saying. You don't go there with a plan. So when you're trying to predict house prices, you have a plan in your head. So if the user gives me this location, I know what the price ranges will be. If the user gives me an area, I know in which bracket they'll fall on, something like that. So you have trained before, right? Now forget the incoming customer that is coming in. There are 1,000 customers that are there, and you just need to push the offers, right? So forget about some unknown customer coming in at this point in time. So supervised learning will be you train on those 1,000 customers, right? So supervised learning, for example, will be those 1,000 customers will already be classified to these clustering bins, right? So cluster 1, cluster 2, cluster 3, they will be given to you. And then when an unknown person comes in, you're just mapping that to a known cluster. What I'm saying is, if you go out there without a plan, well then you don't have data to train. That's all I'm saying. You don't have those clusters already mentioned to you. You're making them in real time as we speak.
I saying that, like you're rather starting with unlabeled data,
Mm-hmm.
yeah,
Mm-hmm.
but you're still looking at data you do have a training exercise here, right? Phase. Maybe
You can say that, but
maybe
then
you don't know what the clusters are.
but then the
right?
catchphrase is working with unlabeled data.
I
That's it.
completely agree. Yeah.
That is unsupervised learning in a nutshell.
But I just had a question on that statement
Mhm.
where you said we're not looking at data. Like there is an absence of training phase.
Oh, no, 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 no. We have to look at data to make any decision, right?
Right.
So
Yeah.
we can't just.
I agree with the fact that it's unlabeled, yes.
Yes.
But yeah.
Okay.
The absence of training phase, I think you made a statement like that. So I just wanted some clarity.
The absence of the training phase.
Yeah.
Right, right. I did make that statement and I still
I
stick to
think
it.
something similar. So I just wanted some clarification on that.
Okay. So,
No, we're good now. We're good now.
okay. We're good now?
Yeah.
That's brilliant. All right. So, again, I think someone else had a question on what are the forms of unsupervised learning that are there. So, we come to the second form. We've talked a lot about clustering. There's dimensionality reduction, right? So, let us try to visualize an image, right? So, this camera is a 13 megapixel camera at least. So, in one frame, you have 13 megapixels. That is 13 into 10 to the power 6 pixels. So imagine the size of that data, right? You don't want systems that will be working with that sort of data, right? So what if I take your picture, right? I know that your hair is black. So if I pick one pixel that represents your hair, I can easily estimate all the pixels around your hair to come up with a fair estimate of what you look like. So the same goes with your complexion, the same goes with your background. So image compression is a very decent example of how dimensionality reduction works. So even in Paint, if we just, or in Photoshop rather, if we go ahead and try to compress the image, right, using different techniques. So there's a technique in Photoshop called spot healing, right? You take a brush, you put it out there, so a pimple-faced guy will be like glowing the next day. Because what you are doing is, you're taking the pixels around those pimples and replacing that pimple with these. So you're basically trying to solve problems based on what is there in your vicinity. So keeping in mind the dimensions that you have, you're trying to reduce it, right? So image compression is one such classic example of dimensionality reduction. So that is it, supervised and unsupervised learning. So let me move on with the next part, structured and unstructured data. Another very debated, very challenging part of machine learning. So again, let me take this with the help of an example. Suppose I give you some forms, and in those forms, you have name, first name, last name, phone number, contact number, whatever, right? So I'll be able to get data that is very structured. So he will have some name, he will have another name, but I'm sure that the name is going to be there. What if I give you blank pieces of paper? What am I going to get in return? Someone will write their nickname, someone will write their phone number, someone will write their first name, last name, name, father's occupation, mother's occupation, and whatnot, right? So you'll throw me all sort of data that is not structured in nature, and I need to make the transition from structured data to unstructured data. So a real world example, Twitter feeds, right? So you have to shove in whatever you want to say within those 140 characters. And the thing that I want to say, the language in which I'll express, it'll be way different than what you will, right? The language will differ, right? So I'll go ahead and say, I like food. Someone else will say, I really like food. Someone else will say, I really prefer food than anything else, right? So there are lots of ways in which you can phrase a sentence. So that is the unstructured present in it, but they all will have something common to say. That is the structure in it. So one such challenging problem in the industry right now is to convert the unstructured data to structured data. So even if I take the example of, say, audio data. So an audio is just an MP3 file, it's just an object, right? So unless and until I don't have a system that can extract the wavelength, the amplitude, the frequency, apply some Fourier transformations in it, digitize the whole process, sample it, and sample it at what rate? 44.1 gigahertz, 8 gigahertz, 8 hertz. What is the underlying problem that we're trying to solve? We're just trying to structure data from unstructured data, right? So this is how we do it. Again, the example of an image. All an image is, in terms of computer vision, is just a bunch of pixels, right? Each pixel will have its own density, its own RGB color properties and whatnot. So what we are trying to do is, from this seemingly unstructured form of data that comes to us, we're trying to extract features and put them in structured form so that they can be analyzed here on, right? So LinkedIn feeds, Twitter feeds, RSS feeds, Facebook posts, everything just comes under the unstructured banner, and everything that you can make sense out of can be you can be looking at data into suppose spread across 1,000 rows with 50 columns. That is structured data feed. So converting the unstructured data to structured data, machine learning comes into play over there too, right? So as data scientists, we need to learn to deal with it, right? So this is a little more details. What data can a machine learn? It's if you look at the leaf nodes, we have audio, video, text, and image, right? So those can be traversed into their parent clusters like continuous data, non-continuous data, and ultimately data has to be atomic in nature in order to produce some value out of it, right? So if I'm looking at video data, each frame will depend upon its previous frame, right? So it's very temporal in nature with respect to time, even audio. So if I say audio, I just pronounce the syllables one by one, O, D, O. So this temporal combination over time gives me a fair estimate of what word I tried to pronounce. So it's continuous in nature that way. So text doesn't have to be continuous necessarily. So there's a very thin line to classifying text. You can visualize it in a way that it's continuous. You can visualize it in a way that it's non-continuous. It really is a subjective call. So images, standalone, always non-continuous stuff, right? So the other catchphrase of this seminar, why Python, right? So is anyone aware of how Python works? Okay, so you're aware of the power of Python, right? So how deep it can come down to talking to a particular machine is almost as fast as C. Is it?
Yeah, I guess.
In terms of speed, can it beat other faster programming languages like Java?
That's a big debate. I don't know. It's a very debatable topic. Right?
So in the context of data science,
You should always argue.
So in the context of data science, I can guarantee you this: Python beats the hell out of everyone, at least in terms of speed. Right?
I have a lot of colleagues who so disagree with you.
Dying to meet them then. Okay, so we have a question from Piyush. Let me take this. According to you, preferred food, I like food, are unstructured, but we can solve it with semantic thesaurus, I guess he meant to say, or word2vec like dictionary. Not requires any machine learning. All right. So Piyush, let me scale up this example with the help of, say, Amazon product reviews, right? So suppose I'm looking at around 5,000 reviews on, suppose, a Nikon D5 300 camera, right? So people will be talking about stuff like this camera is crap or this camera is good, a very high level overview of what's going on, right? And then people will be getting into, some more people will be getting into intricate details. So some more people will be getting into intricate details, such as they want to talk about the battery life of that camera. They want to talk about the shutter speed. They want to talk about, say, the focus, the lens, the body, all those features of a camera. So the question is, given 10,000 reviews, how do I extract some value out of that? It can be done through machine learning. That's all I'm saying. So machine learning algorithms will be equipped to fairly estimate what are the exact features these cameras have and what exactly is being said about those features, so that I can go back to business and tell them, in the next version, please just try to improve your battery life. People are like cursing hitherto about it, right? So does that answer your query, Piyush? Okay. Abhijit has one more question. A person who is from a non-programming background, which language should he start with, R or Python, if he wants to learn machine learning? Okay, that's a very proactive question. I will be comparing the different tools that are used for machine learning with Python. So I'd request Abhijit to have patience. The same question comes from Krunal. What about R versus Python for data science? Right. So Python. Probably, Shoaib, if you look at this survey, uh, does that tell anything about you? So this is a 2015 graph.
Popularity, yes.
Yes. So it's a bubble chart, and according to popularity-based surveys in 2015, Python beats the hell out of everyone, right? It's way ahead of Java. So what is Python basically? Python is a general purpose programming language. It is not some niche programming language that only fits the needs for data science. You can build web pages with it. We can build desktop applications like calculators, face detectors, whatnot. You can start from anywhere and go up to anywhere. It's like a general purpose programming language that I'm trying to see here. But then Python, along with its popularity, has also developed in the field of data science to come up with these sophisticated libraries that have off-the-shelf implementations. So, yeah.
So was this in the context of data science?
The previous slide?
Yeah.
No,
I
all over the world. So I just was trying to imply that how Python as a general purpose programming language serves, so that you have needs other than machine learning, you can just go ahead with that. So yeah, again, Python has off-the-shelf implementation. So what I'm trying to say here is, and I'm not kidding you, right? You can build a face detector in Python with 20 lines of code, and I'm not kidding with this, right? So that's the power scikit-learn will give you, right? You see there, bottom right, scikit-learn. So we have off-the-shelf implementations of a variety or an array of machine learning problems that we can just fit into data and produce efficacious results out of that. That's it. Matplotlib is a native Python interface, which is kind of a clone of what MATLAB does to give you very powerful and interactive plots. So if you're going to go back to the business with that graph on your PPT, you can generate it through Matplotlib just like that. Working with numbers, working with mathematics, working with scientific calculations. So NumPy sits on top of SciPy to do that, right? And working with data frames, Pandas is a very good option, right? So this slide more looks like a hub and spoke model, right? In the center we have IPython. Jutting out of that we have all these machine learning libraries, right? So IPython sits at the center. It is the framework for applying machine learning in Python, and surrounding that we have all those off-the-shelf libraries that you can just use like that. You don't even need to customize anything, right? Just need to pass in the right parameters, that's all. So does Python gel in with any big data framework? Yes, it does, right? So the problem here is very simple. Remember how I talked about business analyst versus data scientist, right? So business analyst, picture a business analyst like a king. He'll be sitting in his throne. People will be approaching with data in platters. He'll try to look at the data and make some sense out of it. That's how a business analyst works. A data scientist will be given a business objective, and that's all he'll be given. So a client will come up to him and say, look, I have $1 million I'm looking to invest. How do I do it? Right? So your job is to go and collect the data from the internet. And you can't just manually log on every website, copy paste every web page to generate some value out of those. You need a framework like Scrappy, which traverses or crawls through each of these web pages via the links present in those web pages one by one with the help of an algorithm of some sorts, get the data, clean it, prune it, and then make some sense out of that, right? So collecting data, not at all a problem with Python. Storage, we not only have integration with NoSQL databases like MongoDB. So MongoDB, I'll just put in a quick line on it, deals with storing unstructured data, whereas SQL tries to store structured data. So we've already talked extensively about structured and unstructured data, right? Computing, it integrates seamlessly over the Hadoop framework. So at any level of the Hadoop architecture, you'll find a Python component present there, whether it be MapReduce, whether it be Scoop, data coming in from external sources, whether it's high-level MapReduce, Yarn, you name it, it's there. So it has even seamless integration with streaming interfaces right now. So as we speak, it's getting more and more leverage on that, right? So for data analysis, we've already talked on pandas. We've already looked through scikit-learn, right? So we'll also look into NLTK in this course. NLTK stands for Natural Language Toolkit, right? So we'll go through some use cases moving forward. So this is the most popular question that I've had up until now in this seminar. So Python versus the other tools that are there in the market. So R is one such tool in the market, right? It's another open source free tool. You can just go ahead and download it. So is Python, right? You have MATLAB, which is commercially licensed. You can't get it for free. You'll have to buy it. And then, so first off, infrastructure. So what am I going to code on, right? Am I going to code on a notepad? Am I going to code on a black screen? Do I have some interactive integrated development environment where maybe I type in a few key phrases and the suggestions start coming in, right? So R has a pretty good programming environment like the RStudio or the R console, right? Even MATLAB has. But then in Python, you have these variety of frameworks, right? You not only have an IDE or an integrated development environment called Spyder, you can start coding in a browser. That's how collaborative that is. So if you feel like just whipping out your phone and trying to practice some Python code, you can do that because it integrates seamlessly with the browser. So the Python shell can sit underneath the browser and you can just fire up Google Chrome and start coding just like that, right? So we even have command line interfaces, but that's just primitive, right? Packages. Well, I'll go ahead and accept that R is quite ahead with respect to the packages that come with respect to Python. But then it's still a very, very nascent stage right now where it's growing a lot. So I myself have enrolled recently in scikit-learn development. So I really get a picture of how they are thinking, the way they are progressing. And if you ask me, within 2020, Python will probably replace R completely, right? So again, skipping over the packages, broad functionalities. So whenever I'm giving data, suppose I'm given data in an Excel file and I generate some analysis out of it, I create some graphs and charts and create a PPT out of it. That is how we visualize end-to-end, right? So what if I want a recommendation engine which can be deployed directly into a website like Amazon.com or Facebook or LinkedIn, something like that. Can R do it? Sorry, it can't. Right? So a framework where an algorithm can sit in a programming language, and that programming language can be just directly thrown into some system with seamless integration. That's the kind of power only a general purpose programming language can give you. And R or MATLAB being niche statistical tools only meant for statistical analysis don't give you that much of power. So with Python, you can leverage that power since it's a general purpose programming language. So threading and parallelizing, right? So I have this use case. Where I was trying to process around 500 megabytes of data, right? I kid you not, in R, it took around 40 minutes, right? Because R doesn't have those parallel computing and distributed computing architectures that strong like Python, right? So with Python, again, with 5 lines of code, I was able to do that processing in 3 minutes. So I guess you can fairly estimate what I'm trying to talk about right now. 40 minutes versus 3 minutes. That's the kind of power you're trying to leverage. That's how real time it gets. So whenever, again, you whip out your camera phone, you don't need to detect a face after it has gone away, right? You need to detect it while it's there, real time, right? So that kind of real time power, Python is just practically a leader, right? So big data capabilities, I've already talked with. Performance benchmark, the last part. Again, we just tried to do an abnormally random mathematical computation and found out that what R can do in 4.8 seconds, MATLAB can do it 1.4, whereas Python can do it in 535 milliseconds, right? So that's how real time it gets. So to answer Krunal's question, yes, I've actually checked out R Hadoop. So R Hadoop is a framework or a package in R that is used to integrate seamlessly with the Hadoop framework. So I'm not saying R doesn't have the capabilities to integrate with it, but what I'm saying is you can develop something native in Python that you just can throw in to any system and it will sit on top of it, making your data analysis automated and seamless. That's it. So you can't come up with a package for R that you can throw into a website, right? So you'll have to get the data from the website, you'll have to load the data into R, run some analytics on it, get some output out of it, and then you'll have to publish the output manually back to your website. That is not how Python works. So Python circles this end-to-end frame in an automated fashion. It has the ability to sit on top of a website to collect data in an automated fashion. It can run the algorithms on that data as we speak. It can produce the output and it can throw in the results back to that website, right? So it's an end-to-end solution always. So we come to some other applications, right? So the way Google works, machine learning, machine translation. So we've all heard and we've all seen the power of Google Translate nowadays, right? So previously it used to work like crap, frankly, and now it has gotten smarter. So let me give you an example. Again, if you throw in a sentence, just before I move forward, I'll like to address another question. Krunal is asking about Shiny. So I've worked with Shiny, right, Krunal? And what you can do with Shiny is you can develop a standalone web server of your own and you can build a dashboard out of it. So what if I have some application or a website pre-built in J2EE or JSP or AngularJS, and I just want to plug in a machine learning algorithm sitting on top of it with the help of R? Can we do that? So can we start calling R scripts from, let's say, JavaScript? I'm not aware of it. If we can do that, then it's good. But then Python has that legacy reputation behind it to integrate seamlessly with any damn programming language you can name, right? So that's how low level that is. I guess that answers your question, right? So again, search engines. I was talking about machine translation and the way Google Translate works, right? So if you throw in a sentence, I like food, and try to translate it in Hindi, it will come up with a translation like "Mujhe bhojan pasand hai," right? So let us try to deep dive into this. I like food. I is a personal pronoun. Like is the verb, and food is a common noun, right? So how does English work? Noun, verb, noun. That's how a sentence is constructed. In Hindi, in turn, it's like "Mujhe bhojan pasand hai." So mujhe, the personal pronoun comes first, closely followed by the common noun, and then the verb follows after that. Mujhe bhojan pasand hai. So Google Translate has become smart enough to learn the English language model, parse it into a noun verb noun form, flip it over to the Hindi model and place it to noun noun verb form, and then get it translated so that the phrase that you use in your sentence is translated as is. You don't lose any meaning by just translating those words directly and mindlessly. You're looking at end-to-end phrases, right? So that is one such application, machine translation, and of course, sentiment analysis. So is this review something good? Is this review something bad? What else is getting tried, right? So with respect to text, those are some of the applications, right? We'll also look at some other forms of multimedia. Audio, so music recognition. You guys might have heard of this mobile application called Shazam, right? You play the song and you fire up the Shazam app and keep the app in front of the song that is getting played, and it will, with reasonable accuracy, predict the song that you're playing, right? So machine learning beneath the sheets. Music classifications, Savan, Gaana.com, right? So whenever you play a song, it automatically recommends the songs that are about to follow, and astonishingly enough, they belong to the same genre, right? So it is going through the temporal patterns of the sound waves, and it is analyzing what best to recommend you so that you will consume the recommendations upfront, right? Speech recognition, speech to text. With Google, we get that with Apple Siri, we get that with Microsoft Cortana as well, right? Speaker recognition. Am I Lata Mangeshkar or am I Vivek? Right? So one such application can be, I don't know, you produce an audio clip in court, right? And the court has to make sure whether it's your voice or not. So there needs to be a forensic report for that. How do they detect your voice against the voice in that audio clip? They just correlate it with the help of machine learning algorithms, that's all, right? So we've talked about text, we've talked about audio, now we're on to images. Face detection, we've already talked about. Face recognition is another application, right? So not just detecting the face, but also whose face is it, right? Object classifications. So can I move on from the paradigm of merely face detection to detecting bottles, plastics, bananas, whatnot, right? Video is just a temporal form of images. So face detection and face recognition, of course, will follow, along with object tracking and motion detection. So motion detection is gaining a lot of traction in the home automation systems, right? So you install a CCTV camera and you go away. You go to work, maybe, right? So nothing is supposed to move there, right? So if the system senses a movement, maybe a whole life human figure moving, how would it be if it can push a notification onto your phone that somebody's just arrived on your house right now? So you can prevent thievery rather than, going after it after that is done. So it's a very proactive approach, motion detection, right? So IB's program, we are piloting this program explicitly for you guys. It's again based on machine learning and it's based on Python. So we'll go through basic Python for those who are from non-programming backgrounds or have never worked with Python beforehand. We'll be going through something called linear regression, we'll do natural language processing, the way Google Translate works, right? We'll do some classification, and by classification, I mean face detection. One such example, right? We'll do some parallel computing. So I think Krunal had the question previously about where he was trying to suggest R Hadoop. So R Hadoop again integrates seamlessly with Hadoop, which is a distributed computing architecture. But Python gives you the power of setting up a parallel computing architecture even within a system. So suppose you have a quad core machine, right? It has 4 logical CPUs. And if you run some mathematical computation in R, the way it works is, suppose it has to do 10 computations, right, to come up with the final answer. So the R command will try to take one at a time, will take those computations one at a time and feed them to one CPU at a time. What Python will do is, if it has 10 computations that it has to do, it will take in 4 and feed it in all those CPUs like in parallel. So you're practically getting 2 to 3 times faster with the help of using Python. We'll explore that framework, right? So how to maximize or optimize your computations. And of course, we'll go through some image compression. And after compressing those images, we'll try to do some face recognition or face detection with the help of SVM. It stands for Support Vector Machine, just a machine learning algorithm that we'll be speaking about once we start. Yeah, sure.
Is there any logic behind clubbing these topics together?
Yes, there is.
Would love to know that.
Okay, so like I said, you want to know about the first one? Or
yeah,
any specific?
First, the third, and fourth as well. I mean, second one is.
Okay, sure. Okay, sure. So basic Python and linear regression is week 1, right? So it's a 4-week module. Okay, so that's why we have 4 modules right now. So basic Python and linear regression is week 1. We'll have weekend classes, Saturdays and Sundays, right? So we'll go through basic Python on a Saturday and learn linear regression on a Sunday.
Okay.
So these are standalone, don't really have that connection.
All right.
It's just clubbing them by
I was
modules.
very curious.
So that is the first part, right?
Yeah.
The third part is when we classify, we'll try to run into many problems, like the computation problem.
All right.
So we'll try to parallelize that.
I mean, what sort of package or
Go ahead.
okay, any parallel computing, right? So, what framework or what package would you be introducing for that?
It's called IPy parallel.
IPy parallel.
Yeah.
Oh, okay, all right.
All right. Okay. So let me just quickly skim through everything else. So again, the fourth point, unsupervised learning and SVM, will be
Very interesting combination there.
yes. That's what I'm here to talk about.
Okay.
Right. So you have these HD images
Alright.
of faces that you're trying to classify.
Okay.
We'll run some unsupervised learning algorithms on it and compress those images, all of them to maybe 10 by 10 or 20 by 20, small images. And then we'll run a classification algorithm like Support Vector Machine to classify faces. That's how it will work, right?
All right.
So that's an end-to-end flow to it. That'll be all about week 4. So some of the projects we'll be working on, we'll be looking at some real-time Amazon reviews. Of course, like I said, we'll be doing face detection. We'll be predicting house prices. And in the space of information retrieval, we'll try to understand, not only understand, but also come up with a pretty sophisticated implementation of our own way of how Wikipedia search engine will work, right? So these will be the projects. Prerequisites, basic knowledge of programming and exposure to some basic statistical concepts. If you don't have these prerequisites, don't worry about it. Before joining this course, we'll have those prerequisites videos ready for you. You can just go through it before coming to class, that's all, right? So who can learn machine learning? Going by the vote and going by the interest shown by everyone over here, probably anyone can chip in and start learning, right? So for the qualifications that I haven't included in this slide, feel free to include those as well. You don't necessarily need to have any prerequisites of that kind whatsoever. Doctors can come in and try to look at genome data. Physiologists can come in and look at archaeological data, stuff like that, right? So again, to repeat myself, we were here before the analytics wave happened. We saw it all happen because we were perched in the center of it. We tried boosting it too, right? We're tied up with industry professionals and corporates. We know exactly what we are looking for, what exactly the industry wants. So we make you readily deployable candidates, right? We've got state-of-the-art labs. So all this face detection, analyzing Amazon product reviews, they need a lot of computational infrastructure, right? We've got those. Of course, I've already talked about the real-life project exposure here. And last but not the least, after everything is said and done, we do work in placing you, right? So our batch will be starting on the 19th of March. I sincerely hope to see some of you over there, right? So for any other information, log on to ivproschool.com. You can call us, you can SMS us, you can drop into our offices, right? So you have any queries right now, I'll be delighted to take them. So I just probably missed one last question from Krunal. Machine translation is more of an NLP problem, isn't it? Yes, it is. Like using language models. Oh yes, we'll be using language models in this course. Or statistical machine translation. Well, machine translation works with the help of statistics, so I don't think there's any practical difference between language models and statistical machine translation. So we'll be looking at free text, trying with the help of hidden Markov models to grammatically tag those sentences, come up with context-free grammars and parse trees for those grammars, flip the models around, and try to make some sense out of that. So I hope that answers Krunal's queries. And with that, we've reached the end of it, right? So, Kunal has a question. So where is the machine learning? So like I said, we'll be learning through a model called the hidden Markov model, which will be implemented with the help of the Viterbi algorithm, which come under machine learning, and they'll help you to grammatically tag a sentence. So what exactly is a noun? So a same word, right, can be used as a noun and an adjective, right? So think about that for a second. I am banking on this to happen. So bank is being used as a verb. The bank closed. Bank is being used as a noun. So looking at the text, it's very important to realize and to make a fairly accurate prediction of what my part of speech for that sentence and for that word is going to be, right? So we'll try to implement some algorithms based on that. Yeah, so some more questions seem to be coming in, man. Okay, how smooth would be the transition for a person from a statistical modeling background to machine learning in terms of job prospects? So the persons who are already having some statistics background, you'll have no problems picking up these algorithms theoretically. You'll probably need to focus more upon your programming skills and how computer architecture works, so that you can parallelize everything and just get some efficacious results within very short time. Can you share the PPT? I'm not sure if I'm allowed to do that. I'll have a talk and get back to you.
We are going to share the PPT and the video to all the people who are joined the seminar.
That's good. That's good. So if
Okay, one more question from Calcutta, Vivek. One
okay,
second.
okay. Can anyone hear?
Hi.
Yeah, sure. Go ahead.
I just want to know that any online classes are available from Ivy on this?
Ishani, would you like to take that question?
Yeah, online classes would be available.
Piyush has a question about course fees, right? So probably not the best time to talk about right now.
Piyush, we can get back. Just let him know that we will get back to him regarding that through email.
So Piyush will be getting back to you on that. Don't worry. So I think it will be decent. Won't be a bit of a big chunk from your pocket. We care about that too, right? So if that's it, then I think we're done here. Again, if any other questions, feel free to shoot. Online, offline, doesn't matter. Right? So Ishani, if okay, Krunal has one more question. So why you made us install Anaconda? So Python, again, like I said, is a general purpose programming language. It has wide variety of distributions. So there's one such distribution called Anaconda, in case you haven't seen prerequisite videos. So there's this distribution of Python called Anaconda, which has these libraries that I was talking about, Matplotlib, NumPy, SciPy, scikit-learn, everything pre-installed in it. So you don't have to download Python, then you don't have to download Matplotlib, then download NumPy, then SciPy, and all these libraries will have version dependencies. So Matplot 2.3.1 might not work well with NumPy 1.3.2, right? We'll have compatibility issues, and you have to take care of that. By installing Anaconda, you don't have to do it. You just get an off-the-shelf implementation of the libraries pre-installed, so that we can just concentrate on working on the problem at hand and not mess around with installing libraries and wasting our time by that way. So is that clear, Krunal? So that's it. If you don't have any other questions, then okay. So Ishani, can I just stop the recording for now?
Yes, thank you so much, Vivek.
Okay, thank you. Thank you to everyone else for taking time out to hear me. So I just wish I tried to invoke some interest in you. These are exciting times and still in a very nascent stage. So I'll request you to hop in as quickly as possible so that you fit in really perfectly, irrespective of your background, irrespective of the prerequisites. So that's all from my side. Thank you very much for joining me. I'll be hoping to see you soon. Enjoy.